Let's discuss what is volume and how does it differ from capacity. Volume is the amount of space that a sample occupies. It's measured in cubic units. In metric, we measure it in liters. We measure it with these measuring devices or pieces of equipment. That's opposed to capacity. And capacity is the measure of one of these objects to hold a sample. Very different measurement. So this is occupying and this is holding. This is the amount of space. Volume is the amount of space that a sample occupies, measured in liters. Capacity is the measure of an object's ability to hold a sample. It's measured in just about any other unit that you can think of. It's measured in liters, it's measured in gallons, it's measured in pounds, it's measured in ounces. But volume is very specific for metric. And we measure volume in accurate ways and in rough ways. When we want to make an accurate measurement of volume for liquids, we'll use things like pipettes that you squeeze the top of, draw in the liquid, and measure it via ticks along the side of the shaft. And we can also make accurate measurements of higher volumes using a graduated cylinder. And in fact, your lab has a great video attached to it on how to use the meniscus for most liquids that you'd put into a graduated cylinder. And in those liquids, the meniscus, or the shape of the fluid, is actually concave. No matter the shape, you always measure the volume of the liquid in the center of the meniscus shape. So for most liquids, not mercury, but most liquids, you're measuring at the bottom of the meniscus. And that's where you take the volume measurement. And check out that video that's associated with the labs, because it's well done. When you only need a rougher volume estimate, you can use a beaker. Okay? Beakers are great for carrying fluids and for measuring them roughly. Erlenmeyer flasks are glassware that has this shape to it, and it's used for reactive solutions. If you see up here, it is not as exposed to the atmosphere as the beaker is, which has a wider opening. So these are used for reactive solutions, and you can put a cover over it so you can really seal off the atmosphere from the reactive solution in a way that's easier to do than using a wider beaker. And it's also used for solutions that need to be heated or stored. So I love Erlenmeyer flasks. Use them for a lot of things. They're good for rough estimates as well. And they are good for many different things. Reactive solutions, solutions that need to be heated, solutions that need to be stored. Test tubes are glassware pieces that are generally used for lower volumes than an Erlenmeyer, and they're used for chemicals that also need to be heated and mixed and react and store, but lower volumes. The vocabulary of volume will help you to take apart scientific studies and word problems. And I wanted you to understand that when you talk about a measure of an amount of a material or an amount of a sample, you're talking about a volume measurement with a unit that is a liter. or a kiloliter or a milliliter. Okay, so you are talking, when you hear about amounts of samples, think volume. And you have a part in your lab where you have to pick the appropriate glassware for the measurement that you're doing. Very important in planning out labs. So this is a really functional part of your lab. And what you want to do is you want to think about the rough volume that you're looking for, and then think about the glassware that can measure above that volume. You don't want your measurement to equal the exact maximum volume of your glassware, because then you're right up to the top and you may find that you're not getting as accurate a measurement as if you were able to see the ticks more precisely at a lower level. So think about what you're measuring at what your rough quantity is and rough amount, and then choose a piece of glassware that is at least above that amount. And then when you're thinking about, and that's the point of this lab post right here. So there is one section where I think you could have two different measurements here. And I want you to think about, for E, is this a situation where heat and temperature is an issue? Is this a situation where reactivity of this sample is an issue? And I think it will help you when you look at E to decide which piece of glassware you're using. Very important skill to setting up your procedures. I did myself a favor and I took all of these pieces of glassware that were laid out in here in the lab, and I put them in order from smallest to largest next to it. And then I took a look at what my perceived volume would be, and I matched it up to a piece of glassware that was slightly larger, right? So I hope that helps you, because this could be a little bit confusing in here. You can write it all out and make yourself easier, make it easier for you. I'm also going to talk to you a bit about another part of your lab, which is working with the triple beam balance. There is a great video for the triple beam balance inside your lab. I think you should watch it. The triple beam balance is used for larger masses that are generally over 300 grams. Under 300 grams, 200 grams is a good measure for an analytical balance, but triple beam is for more than that. And the way you will look at this triple beam measure, remember, here's the triple beams. There's one beam measure that measures in the hundreds of grams. There's one beam that measures in the tens of grams, and there's one beam that measures in the ones. And you're going to match that up with hundreds, tens, and ones. Then you're always going to have your last measurement as an estimate. So what you're doing here, you can look at this on the PDF later, but what you're doing is you're looking at the largest measurement first, 400, put in the 4. Then the tens measurement, the second largest measurement, 30, great, put in the 3. Then you go to the ones measurement. This measurement is a bit hard to see, so come down to this zoomed out area. It's a lot easier to see down here. They put it in for your convenience. And you cover 4 ones with your measure. And then you go a little bit beyond that, but you put up your 4 ones, and then you estimate in your tenths. You come down here, it's tough. You know, is that 0.6 of a gram? Is that closer to 0.5? You make an estimate and you put it in the tenths place and then check it. Your last digit should always be an estimate. I hope that helps you out. I'll see you on the next video.